Billions of years ago, our solar system was nothing more than a vast cloud of gas and dust drifting through space. This primordial nebula, composed mainly of hydrogen and helium, also contained traces of heavier elements formed in ancient stars. Then, around 4.6 billion years ago, a nearby supernova explosion sent shockwaves rippling through the nebula, causing it to collapse under its own gravity. As the cloud contracted, it spun faster and flattened into a disk, with most of the material gathering at the center to ignite as our sun. Within this swirling disk, tiny particles of dust and ice began to stick together, gradually forming larger and larger clumps through a process called accretion. These early building blocks, known as planetesimals, collided and merged, growing into protoplanets. In the region where the Earth would eventually form, temperatures were just right for rock and metal to solidify, but too warm for ices to survive. Over millions of years, planetesimals collided violently, their impacts generating immense heat and releasing energy that helped shape the young planet. As Earth grew, its gravitational pull became stronger, attracting even more material from the surrounding disk. The collisions and accumulation of mass caused Earth's interior to heat up, eventually melting much of the rock and metal. This allowed the denser elements, like iron and nickel, to sink toward the center, forming the core, while lighter materials rose to create the mantle and crust. This internal differentiation gave Earth its layered structure, which persists to this day. During this tumultuous period, Earth was bombarded by countless asteroids and comets, many of which carried water and organic molecules. Around 4.5 billion years ago, a Mars-sized body, often referred to as Theia, is believed to have collided with the young Earth in a cataclysmic impact. The debris from this colossal event was thrown into orbit around our planet, eventually coalescing to form the Moon. This dramatic collision not only gave Earth its satellite, but also tilted the planet's axis, setting the stage for the cycles of seasons we experience today. As the barrage of impact slowed and Earth's surface began to cool, volcanic eruptions released gases trapped inside the planet, including water vapor, carbon dioxide, nitrogen, and other elements. These gases formed Earth's first atmosphere, which was vastly different from the one we breathe now. Over time, as the planet continued to cool, water vapor condensed to form the first oceans, covering much of the surface and setting the stage for the emergence of life. Through the slow process of plate tectonics, continents began to form and drift over the surface, constantly reshaping the face of the planet. The dynamic geology of Earth, powered by heat from its core, continues to drive the movement of continents, the formation of mountains, and the eruption of volcanoes even today. Thus, the formation of Earth was not a single event, but rather a story of cosmic evolution, violent collisions, and gradual transformation. From a cloud of stardust to a vibrant, life-supporting world, Earth's journey has been shaped by both destruction and creation on a truly grand scale. Understanding these origins not only connects us to the ancient history of our planet, but also reminds us that Earth, like all things in the universe, is part of a continuous cycle of change and renewal.